Scientists measure the distance to the moon by bouncing lasers off mirrors left on its surface by space missions. By timing how long the light takes to travel from Earth to the moon and back, they can determine the moon's distance with millimeter-level precision and track tiny changes over time. That distance varies throughout the moon's monthly orbit. On average, it is about 385,000 kilometers. But because the orbit isn't a perfect circle, it fluctuates by roughly 20,000 kilometers. This variation is why a full moon can sometimes look larger in the sky, a phenomenon known as a supermoon. The motions of Earth and the moon have many intriguing consequences, and studying them over long periods helps researchers understand how both bodies have changed throughout the 4.5 billion years since they formed. So why is the moon slowly moving away? It all comes down to tides. Tides are caused by differences in gravitational pull across a world. The moon's gravity is about 4% stronger on the side of Earth that faces it than on the far side, because gravity weakens with distance. This tidal force stretches Earth's oceans into two bulges, one facing the moon and another on the opposite side. Because the moon's gravitational pull isn't uniform everywhere, water rises and falls as Earth rotates, explained Stephen de Kirby, a research fellow in physics and astronomy at Minnesota State University, USA. The moon's gravity is strongest on Earth's near side, drawing water into a bulge pointed toward the moon. On the far side, the pull is weaker, science alert notes. As Earth spins, this bulge moves, staying roughly aligned with the moon's position. In cities like New York or Los Angeles, sea level can change by around 5 feet due to these tidal bulges, de Kirby added. Among other effects, this interaction transfers energy to the moon, gently speeding it up and stretching its orbit. As the Earth-Moon pair drifts apart, Earth's rotation also slows slightly, making the day a little longer. There's no cause for alarm. We'll still have eclipses, tides, and 24-hour days for many millions of years. The moon likely formed about 4.5 billion years ago, when a Mars-sized protoplanet struck the young Earth and blasted material into space. That debris eventually coalesced into the moon, which initially orbited much closer to Earth, so it would have looked far larger in the sky. What about the very distant future? Could the moon ultimately escape Earth's gravity altogether as it recedes? Perhaps after tens of billions of years, Earth's spin could slow enough that the gravitational tether effectively loosens. But these events are so unimaginably far off that there's no need to worry about them today. Recession rate approximately 3.8 centimeters a year. Earth's tides rub against the seafloor friction, stealing a tiny bit of Earth's spin and giving that angular momentum to the moon, which moves into a slightly higher, wider orbit each year. Laser round-trip time approximately 2.5 to 2.7 s. Light takes approximately 1.25 to 1.35 seconds to go, one way across approximately 384,400 kilometers. Scientists time the full out and back trip to millisecond precision to get the distance. Retroreflectors on the moon. Apollo astronauts and Soviet rovers left arrays of corner-cube mirrors. These bounce light straight back to its source, enabling ultra-precise ranging for decades. Average versus extremes, perigee, apogee. Because the moon's orbit is slightly elliptical, not a perfect circle, its closest point perigee and farthest point apogee differ by approximately 42,000 kilometers. Supermoon versus a full moon near perigee looks a bit bigger and brighter. Supermoon near apogee, it looks smaller and dimmer. Micromoon, same moon, different viewing distance. Tidal locking, same face. Over time, Earth's gravity slowed the moon's rotation until it matched its orbital period, approximately 27.3 days. Result, we always see nearly the same lunar hemisphere. Synodic month, 29.53 days. Full to full takes longer than one orbit because Earth and the moon are also moving around the sun. The moon has to catch up to the sun-Earth line. When days get longer, ms per century, tidal friction converts a tiny bit of Earth's spin energy into heat and lunar orbital energy, very slowly stretching the length of a day. Shorter ancient days, approximately 18H geologic records of tidal layers show more days fit into a year in deep time, implying shorter days and faster Earth rotation. Sun's tidal roll approximately 30 to 45%. The sun is far more massive but much farther away. Its tidal pull is weaker than the moon's, yet still significant, shaping spring and neap tides. Solid Earth tides tilde up to 30 centimeters. Not just oceans, Earth's crust itself flexes under lunar and solar gravity, rising and falling subtly each day. Earth-Moon barycenter inside Earth. Both bodies orbit their common center of mass. Because Earth is much heavier, that point lies beneath Earth's surface. Orbital eccentricity approximately 0.055. A small eccentricity means distance varies through the orbit, causing perigee, apogee, and the related size brightness changes. Apsidal precession approximately 8.85 years. The orbit's ellipse slowly rotates in space, shifting when perigee happens and modulating supermoon timing on multi-year cycles. Inclination approximately 5.1 in rare eclipses. Because the moon's orbit is tilted relative to Earth's, the moon usually passes above or below the sun-Earth line, so eclipses don't happen every month. Eclipse seasons approximately 173 days, about twice a year. The sun is close to the lunar nodes. For a few weeks alignments are possible, allowing one or more eclipses. Saros cycle at approximately 18 years, 11 days. Eclipses repeat in families when the Moon-Earth-Sun geometry is symbolic draconic. Anomalistic months realigns on this timescale. Changing basins equals changing friction. Tidal energy loss depends on ocean depth, coastline shape, and seafloor roughness. As plate tectonics reshapes basins, the recession rate changes. Tidal rhythmics as clocks. Layered sediments deposited by tides record daily, monthly, and seasonal rhythms, letting scientists infer ancient day counts and month lengths. Librations seeing approximately 59% because of tilt, eccentricity, and a slight wobble. We peak around the edges, revealing about 59% of the lunar surface over time, total versus annular solar eclipses. If the moon looks larger than the sun near perigee, it can cover the sun completely total. If smaller near apogee, a bright ring remains annular. Future end of total eclipses approximately 600 Mir. As the moon recedes, its apparent size shrinks. Eventually, it won't fully cover the sun, only annular or partial eclipses will occur. Anomalistic month, 27.55 days. Perigee to perigee timing is slightly longer than the sidereal month because the line of apsides is itself rotating precessing. Angular momentum transfer. Tidal bulges are dragged slightly ahead of the Earth-Moon line by Earth's rotation. Their gravity tugs the moon forward, raising its orbit more energy while slowing Earth's spin. Tests of gravity and relativity, millimeter-level distance data over decades checks Einstein's predictions, for example. Equivalence principle, inverse square law, and sets tight limits on any drift in G. Near-far side differences. The far side's thicker crust and distinct geology likely reflect early tidal heating and asymmetric cooling when the moon was molten and closer to Earth. Past tidal heating of the moon, when the moon orbited closer. Varying tidal flexing produced internal heat, influencing volcanism and interior evolution. Today that heating is minor. Tides affect coasts and planning. Changing lunar distance subtly tweaks tidal ranges over long timescales important for habitats, sediment transport, navigation windows, and coastal engineering. Mutual tidal locking far future. Given enough time, Earth's rotation could slow until one hemisphere always faces the moon, just as the moon already does with Earth. Giant impact origin and isotopes. Moon rocks share oxygen and other isotopic signatures with Earth's mantle, supporting the idea that the moon formed from debris after a colossal early impact.